Hello students, welcome to today's lecture. So in this lecture we are going to see about internet connectivity and internet based communication. So the term internet connectivity, okay, so it refers to the way people who are connected to the internet. So and it may include dial-up telephones and always on broadband connections and wireless services. So in this part, the IoT means connecting the devices and the user interface with the help of a network. So among these, the wireless access to the network is the newest part, which is internet, and it is start with early 2000s. So it has only reached to a small group of users in the starting part, but it has reached. So over around 50 million people are connected to the internet. So internet access is the ability of the individuals and organization to connect to the internet using computer terminals, computers and other devices, and to access services such as email and the World Wide Web. So we are going to see in detail. So internet, basic internet connectivity. So it is a connected devices for and a gateway for sending the data frames of the devices or to the devices. So we are the sending and receiving the data. So through the data communicate over the network as a packets. So which can communicate through a set of routers at the internet. So the process which can manage, acquire, organize and analyze the data of the IoT device for applications, services and business process. So the device, these are all the features. Okay, so the process managers which acquire the data from the input side, that is from sensor side, that is physical connectivity through a world. Okay, so the physical parameters of the quantity which are measured through the input devices which can be managed. Okay, so managed, acquired and organized and analyze the data of the IoT devices for the particular applications, services and business process. So these devices which performs the controlling and monitoring functions using the messages, data stacks and commands which sent over the internet through the applications, services or business process. So following these, there are some key terms which helps to connect the IoT devices through the network. So the terms which are headers, IP headers, so TCP headers, protocol data unit, so TCP stream, maximum transferable unit, so packet, and it is a set of bytes. Okay, so it is a fixed maximum specified size. So it can transfers from network layer and communicates to router from one router to another. So and then IP packet. So it is a data stack which includes IP header. So data segment which refers to the data stack from the application support layer for transport, and a network interface. So it is a system software component. So hardware for facilitating communication between two protocols with the layers, computers, nodes in a networks. So port is an interface to the network which is using a protocol that sends an application layer data stack to the lower layer for transmission. So socket is a software interface to the network that links data to the data stack using a port protocol and IP address. So host, which is a device or node that connects to a network of computers. So IP host is the one which uses the internet protocol suite. So subnet is a network which is a logical and visible subdivision of an IP network. So routing preface, so it is a 32 bits IP address which can be divided into most significant bits consisting of 8, 16 or 24 bits and remaining least significant bits. So host identifiers, when a network which subdivides into subnets and subnet has a number of hosts. So data flow graph which denotes a graphical representation using arrows from one stage to another, and acyclic data flow graphs which refers to a data flow graph where only one set of inputs generate only one set of outputs for the given input set in the data flow graph model. And also directed acyclic graph, so which means a acyclic data flow graph in which none of the output cycle backs to the previous processing stage or level or rank which has an input during the data flow. So these sections which describe the internet connectivity principles for connected devices. So we can go for the internet connectivity. So this is the source IN network layer which is connected to IoT and machine to machine communication. So this diagram which shows the representation of source and network layer which connected through a set of IP routers. So these are the set of IP routers for data packets from an IP address through the network layer and also communicating with the IoT and machine to machine IoT applications and services layers using TCP IP suite of application protocol. So here the physical layer, data link layer, network layer, then transport layer and IoT application layer. So the set of routers which is connected to the physical layer, and then this is a source and IP address, and it is a source and IP address for the gateways. So and then it has a data consolidation framework and IoT communication framework. This is the input side, that is from smart sensors application framework and IoT communication framework and sensors for applications framework and then IoT communication framework. So in this part the IoT internet connectivity is established is through a set of routers in a global networks which carries the data packets as per the internet protocol from a source end to another end and vice versa. So a source which sends the data packets to the destination using IETF standards. So it also shows that a communication framework which uses an IP address. So IP address and communicates with the IoT and machine to machine IoT application and also services layer using TCP IP suite of application protocols to a destination IP address. So it also shows that a communication framework which uses an IP address, okay, and also it connects with the TCP IP suite of application protocols to the destination IP address. So here the internet connectivity is through a set of routers. So here the routers plays a major part, which is in a global network of routers which carry data packets as per the internet protocol from a source end to another. Okay, so here the source end which sends a packet to a destination using a that IETF standardized formats. So the data transmission using IP. So when data which transmits from layer to layer I to the next layer J, which the following actions are to be takes place. Each layer processing of data is as per the protocol which is used for communication by that layer. So each layer which sends the data stacks received from the previous upper layer plus the new header, and thus creates a fresh stack which after actions specified at that layer. A layer J will specify the new parameters as per the protocol and create a fresh stack for the subsequent lower layer. So the process which continues until the data communicates over the complete network. So this process will be repeating until the data, okay, so data which is communicated over the network. So remember that the IoT application layer is the highest in the modified OSI model and the physical layer is the lowest. So thus the data transmits from the layer I to next layer J. So when I is greater than J, so when it transmits from the application layer to the physical layer. So when data is received at the next layer I from a layer J, so that is the IoT physical layer to the IoT application, the actions. So the following actions which are discussed. So the upper layers which is use the headers words alone. The lower layers such as data link layer protocol such as Ethernet 802.3 which provisions for the trailing bits also. So in addition to the header words. So the trailing bits usage can be as an error control bits and end of the frame indicating the bits. So here with this TCP IP suite during internet communications. So the Ethernet frame communicates between the data link layers of two computers on a local area network. So 802.3 specifies the maximum frame size of 1518 bytes, and later it can be increased to 1522 bytes and consisting of 32 trailing bits. So these are called as frame sequence check, FRC. and also cyclic redundancy check CRC bits. So these CRC bits append during transmission. So the receiving end which recalculates the CRC from the received data bits. So if both of these match, then the frame is in the sequence is accepted. So else an error is report. Okay. So the CRC bits which appends during the transmission, and then the receiving end which recalculates the CRC from the received data bits. So we compares with these received data. So if that these data is matched or sequence is accepted, so hence the frame is ready. Okay. So otherwise a report error will be received. So in terms of the data is missing. Okay. So only 4 OSI layer models such as 7, 4, 3 and 2 are specified at the TCP/IP protocol suite for communication. So layer 1 is the which is for communication protocol for physical layer to routers, and then it shows the communication between the source and the destination. So internet based TCP/IP communication uses layer L7. Okay, so the layer 7 which is the port for data from the application layer. So transport layer L4. So the transport layer which is L4 and internet L3 and link layer L2. So this is from L4. Okay, so this is from L4 and the L3. So the data link layer, that is L2. Okay. So it is a TCP/IP suite for 4 layers generating data stack for the network and for the physical layer during internet communication. So the data segment which is maximum 2 power 32 or 2 power 32 is accepted from the L7 layer for transport layer TCP. So L4 then generates a TCP stream. So the stream which packetizes the internet layer L3. So alternatively a datagram is maximum of 2 power 14 bytes is accepted from L7 layer for transport layer UDP usage. So the L4, okay, here the L4 which generates a UDP datagram, so which is of maximum 2 power 16 bytes. So the stream which packetizes at the internet layer L3 into packets, okay, so L3 into packets. So the packet which is sent from L3 has maximum of 2 power 16. Okay, so the packet also maximum of 2 power 16 including L3 header. So this is the L3 header and this is the UDP header plus datagram. So the datagram is sent for L3 also having the datagram. Okay, so it is also having 2 power 16 bytes. So the internet layer which uses the IP protocol, that is IP version 4 and IP version 6 and RPL. So these are the 3 protocols which is using. So the routing protocol for low power lossy networks. Okay, that is LLNs for and RPL routing protocol. So these are all used in internet protocols. Okay. So the packet routing occurs at each router which has an information about the path to the destination. So when a number of paths are available, then the number of packets of the same source simultaneously follows different paths from a router. So destination end transport layer which reassembles the packet according to their sequence in the source transport layer data streams. Then the reassembled data segments transfer to IoT application layer at the destination end. So the data link layer which uses a protocol at each sub layers. Okay. So for example, Ethernet IEEE 802.3, MAC and PPP, ARP, RARP and NDP, etc. So Ethernet is protocol for logical link layer on a LAN, and MAC for media access control, and PPP for point-to-point protocol, and ARP means for address resolution protocol, and RARP reverse address resolution protocol. So the resolution which means using a network data stack to find the MAC address, and reverse means MAC address used for finding IP address. So NDP is for network discovery protocols. So this is about TCP/IP suite. So when the data received at the next layer I from next layer J, the IoT device physical layer to the application, that actions are performed. Each layer performing the processing as per the header field bytes, so and which are received according to the protocol to be used for decoding the fields for required actions at that layer. So each layer receives the data stacks from the previous lower layer, and after the required actions, it subtracts the header words and creates a new stack specific for the next higher layer. So the process continues until the data is received at the port of the highest application layer. So upper layers which uses the header words alone, lower layer such as data link layer protocol, and the 8023 which provisions for trailing bits in addition to the header words. So trailing bits which can be a error control bits and end of the frame indicating bits. So this each router has the information about path to the destination. So when a number of paths which are available, then the number of packets of the same source simultaneously follows different paths from a router. So it receives and forwards data to the next layer using these protocols, version 4 and version 6. So here we are going to see about internet protocol version 4. So in the internet protocol is abbreviated for as IP. Okay, so internet layer protocol is defined as an IP. So it refers to the process when a packet which transmits the data. Okay, so the transmission is acknowledged data flow. So the transmission is unacknowledged data flow. So IP packet segment which consists of data in which the internet layer receives on transfer from the transport layer to the receiver ends when using the IP protocol. So this is the format of IP4 protocol. So let n be the total number of header words. So in this figure which shows the data stacks which received or transmitted or to a network layer from the previous diagram. So the IP packet consisting of IP headers, fields of n words, which is 160 bits, and extended header option words. So the extension is done when required actions and using the data stacks from for the transport layer. So the internet layer protocol, it is uses the IP data stack which includes the IP header fields. So it shows the start and end bits. Okay, so it shows the start and end bits, numbers in each word and data. So that it has a data stack and then option header words, source address, destination IP address, checksum, a type of protocols, and then TTL. So the time to live logic, and then first byte sequence number in the string, and flags, fragment, offset. So length of that is packet length. So and then service types and precedence with another type, and also IP version. So it has a header part and a packet length, and then extended header with the calculation. So q is equal to 32 bits into n minus 1. So n is the number of words, that is 5 words for header plus options plus padding words for maximum extension. So it maximum it is 2 power 14 minus n into 32 minus 1. So here the data stack from or to the transport layer which has a maximum data size. Okay, so which has 2 power 14 words or 2 power 16 bytes. So it's a data stack which is received or transmitted to a network layer, and IP packet consisting of IP header. Okay, so it has an IP header of 160 bits. So the data stacks received or transmitted at or to a network layer, and IP packet which consisting of IP header field of 160 bits and extended header up to bit queue. So that is extended when required, plus data stack from or for the transport layer. So the features of IP4 which is discussed in the slide. So the IP header which consisting of 5 words. Okay, so the header can extend when using an option and padding words. So the data stack to the network layer has maximum v is equal to n plus length words, where v is less than or equal to 2 power 14 minus n. So header fourth and fifth words are source IP address and destination IP address. The IP protocol transport is half duplex unacknowledged data flow, that is from internet layer at one end, that is n1, and to the internet layer of another end is n2. So each IP layer data stack is called IP packet. So and this packet is not guaranteed to reach the destination when the transport layer protocol is UDP. So when you are using UDP, the transport layer protocol, the destination which is not guaranteed. So whether it is reached or not. So the guaranteed to reach the destination when using the transport layer protocol is TCP. So one packet which communicates in one direction at an instance. So the Internet Protocol version 6. So it has some provisions for larger addressing space. So and as it has permits hierarchical address location and thus route aggregation which across the internet and limit the expansion of the routing tables. So provisions are additional optimization for the delivery of services using routers, subnets and interfaces. So it also manages device mobility, security and configuration aspects. So the expanded and simple use of multicast addressing. It provisions jumbograms, that is big size datagrams and extensibility of options. So the features were IP version 4 is of 32-bit size. Okay. So IP version 6 which has a size of 128 bits. Okay. So this is the major difference between IP4 and IP6. So it has 128 bits and IP4 has only 32 bits. So IP version 6 has vastly enlarged address space which compared to IP version 4. So IP version 6 address provides a numerical label. It identifies a network interface of a node and other network nodes and subnets participating in the IP version 6 internet. So a device is the node in the network when it communicates on another network. So this is the header format. So it has a version, traffic class, flow label, payload length, which is of 16 bytes, and then next header, hop limit, source address and destination address. So the version which represents the version of the protocol, for example 0100. So traffic is 8 bits. So these are divided into two parts. The most significant 6 bits are of a type of service. Okay, so the type of service to let the router which is known. Okay, the router which is known to the what services should be provided to this packet. So the least significant 2 bits are used for EC, and that is explicit congestion notification. So the flow label which is of 20 bits, the label which is used to maintain the sequential flow of the packets belonging to the communication. The source labels the sequence to help a router identify that a particular packet belongs to a specific flow of information. So these field helps avoid reordering of data packets. So it is designed for streaming real-time media. So payload length, this field is of 16 bits and is used to tell the routers how much information a particular packet which contains in its payload. So the payload is composed of extension headers and upper layer data with 16 bits, which is up to 65535 bytes. And if extension headers contains hop by hop extension header, so then the payload may exceed 65535 bytes and this field is set to 0. So next header, okay, so the next header is of 8 bits, which is used to indicate either the type of extension header or if the extension header is not present, so it is indicates the upper layer PDU. So the values for the type of upper layer PDU are same as IP4. So then hop limit. Hop limit is field is used to stop packets to loop in the network infinitely. So this is same as transport logic, and then in IP4, and then the value of hop limit field is decremented by 1 as it passes a link. Okay, so hop and the router or hop. So when the field reaches 0, the packet is discarded. Source address it 128 bits and destination address 128 bits. The source indicates the address of the originator of the packet. So it the field provides the address of intended recipient of the packet, source and destination. So RPL comes into picture. So the RPL, which stands for routing protocol for low power lossy networks. So it refers to a constrained nodes network which has low data transfer rate related to IP and a low packet delivery rate and unstable links. So the IETF has given specifications for RPL over the routing over a lossy network. So RPL is a non-storing routing mode. So the IoT M2M low power lossy network environment, which uses RPL protocol, internet layer version 6 receives and transmits from 2 or adoption layer. So the IoT machine to machine communication low power loss environment uses RPL protocol. So the IP version 6 receives and transmit from 2 data abstraction layer. So internet layer IP version 6 receives and transmit from 2 data adoption layer when using IEEE 802.15.4. So the wireless band devices is also using this type. So low power nodes need to confine communication to the nearest levels upwards or downwards. So the lossy environment needs disjoint nodes in case of error or no acknowledgement. So a repeat transition can be made using the same or previous instance. So data communicate with optimum data size at an instant. So data flow that is between the nodes is for destination oriented directed acyclic graph, that is DODAG model. So directed acyclic graph is a data flow model between the nodes, and destination oriented means either upwards or downward director in a tree like structure. So with the DODAGS. So the features of RPL. So the data flow direct downwards in an RPL instance from a root at transport layer to child nodes, and from child node to a leaf node at physical layer device node. The data flow directs upwards in a RPL instant from a leaf or child node to another child node and then to root. So DODAGs are no share nodes. So these features having the routing protocol for the low lossy networks LLNs, and then so the features of a routing protocol. Okay, so it is a routing protocol for lossy networks. The features of RPL, the routing protocol for low power lossy networks, and RPL control messages or destination. So object advertisement object DAO and DODAG. So the information object DIO and then DAG information object DIO. So transfers data at an RPL instance data point to a point, that is one device node to another device node, as well as point to a multi-point, and then one to many device nodes or multi-point to point, that is many device to one receiver node. So they also sends or receives multiple DAGs at each instance, which sends data from DOGs to DODAG root and DODAG leaves to support low transfer rate and compared to IP low packet delivery rate. It supports unstable links and also has optimization objective for RPL instance. So it supports coexistence of different optimization objectives using multiple RPL instance. So it also supports nodes and inform parents of their presence and reach ability to descendants using DIOs. It also supports soliciting information of a DO DAGs using DAS. So it supports destination information nodes for discovery of an RPL instance and know about the configuration parameters and select DO DAG parents using DIOs. So far we have seen the internet connectivity and internet based communication using IP version 4 and IP version 6. So thank you for your listening.